Celestine is from Central South University of Forestry and Technology, China. Dr. Celestine will explore about artificial intelligence on Energy 4.0 with us. Hearty welcome to you, and it's so great to have you here. For the next
Thank you.
25 minutes, we will travel with you, sir, and the session is yours.
Okay, thank you very much. I want to appreciate everyone for this opportunity to be in this ICC TSAI Researchers Hub. Do I have the host now? Okay, so we are on into artificial intelligence on Energy 4.0. All protocols observed. Thank you again, the conference organizers, for making this worthwhile. I'm bringing people all over for this international conference on computing and technological solutions with artificial intelligence. Now, here we'll look at Education 4.0. When you mention Education 4.0, what are we actually talking about? Artificial intelligence on Energy 4.0. The last two speakers have been speaking on different areas of artificial intelligence, which is very lovely. Then we'll look at why AI is the future of energy. Then why it all depends on the analysts, the energy experts. Why are we here today? The Industrial Internet of Things in energy management and industrial artificial intelligence-based demand prediction, detection, and response. We also look at the industrial smart grids, transportation and distribution, and energy storage. So what is Education 4.0? When we use the word Education 4.0, it's a desired approach to learning that aligns itself with the emerging fourth industrial revolution. So we are still talking about fourth industrial revolution, but some of us are already projecting into the fifth industrial revolution. But fourth industrial revolution has not gone worldwide. It has not gone everywhere. We still have issues in the developing countries. We still have privacy issues. We still have, all kinds of, what do you call it, problems that needs to be solved, which some of them we are light in this discussion today. So Education 4.0 is powered by artificial intelligence. So this industrial revolution focuses on anything smart, smart technology, smart money, smart energy, the AI, the robotics, all of which have impact on our everyday lives. So we are actually talking much more of something that has to do with sustainability. It has to do with involving the human into what we are doing and trying to make it easier for industry and academics, and also in productivity. So artificial 4.0, we begin looking at personalized learning. How do we personalize our learning? Good enough, AI Education 4.0 has been projected even before this COVID-19 exploded. That means that we are talking about personalized learning where you can be anywhere in the world and take a course, just like what we are doing now. You can be anywhere in the world and be part of a conference. These are all personalized learning. The Education 4.0 has to do with remote learning opportunities where you can be, you can be any part of the world, and then you have no excuse not to be part of the learning system. Then we have the plethora of education tools where different, information is put together. We have data at the fingertips. Most organizations like IEEE now, we have database. Most journals now, they'll tell you when you're writing a paper that you should try to bring your data so that people know what you are doing. Now, because you cannot work on AI, I'll come down to that later. You cannot do anything AI without data. Without data, you can't predict without data. That's why we have problem with COVID-19. In terms of different drugs, this medicine is working, they say the other vaccine is not working, because we don't have data. And then when the data start coming and people start seeing the effects of some of the vaccine, some of them were rushed, and some of them were not actually done very well. So all these are the issues that Education 4.0 is trying to solve by making data to be at the fingertip. Easy and accurate assessment, because when you have data, it's easy for you to do an assessment. Then we have the project-based learning. This is what we try to teach even our students, that every course should have a project-based learning. And this happens to be part of the HE, United Kingdom academic system, in terms of trying to make sure that people, students are given projects that will help them understand algorithms, understand principles, understand steps by step, methodology of doing things. So the same Education 4.0, when we talk about artificial intelligence, will come into what we have as complex problem solving, critical thinking. We have the creativity, people management, coordinating with others. We have emotional intelligence. We have judgment and decision making, service orientation, negotiation, and cognitive flexibility. These are digital skills education that 4.0 demands, which is necessary for students for us to have better students and have better education system. So now look at, for example, I was talking about the what AI can do. I could give you a lot of examples of what AI is doing and what it's doing. In Modu Yuan Metro Station, for example, in Beijing, part of an effort to contain the spread of the coronavirus by a Chinese government. So this company called Megvi, a Chinese tech company, they screen commuters for fevers as they enter the Modu Yuan Metro Station in Beijing. So a security man does not need to be there to catch, maybe to get infected with the virus. What he only needs to do is to sit in one place and use this system, AI-powered system, to kind of, screen the commuters. And once you are noticed, you are asked to move to one particular side. Yesterday, I was watching the news, and I saw that the Israeli government are also doing something whereby you take your saliva and then it will be easily checked if you have COVID. And many other countries are busy doing something, that using AI-powered system to solve human problems. So Education 4.0 again is about evolving with the times. For instance, for higher education, it means understanding what is required of our future graduates. So it also means trying to help to prevent future outbreak of diseases, neurologic diseases, all type of diseases that are coming in. But AI is becoming a tool, not just working as a computer scientist, but we are having AI working in the medical industry. We're having AI in the civil industry. We're having AI in mechatronics. So we're having AI all around. So imagine a global network of sensors and systems that provide an early warning system when infectious diseases threaten to become pandemic. That means if AI has been up and doing before the COVID, we should have actually prevented the COVID. You see, that is why Education 4.0 is very important. So building one is enormous taxing undertaking, and we are trying to, so you see, most of the government, now, most governments are now bringing up funding in AI. They are trying to get in more AI, more thing, which is very lovely in terms of this field, But if they had done it, look at America, for example, millions of people have been lost, are dead, So we could have prevented a lot of things if they had listened to people who projected AI. Now we are thinking of AI 2.0, which a country like China is already ahead. In 2030, China is projected to have AI 2.0. That is what we call the next generation artificial intelligence. So, but now the issue is, now when you have to do with data, because AI has to do with data, then it's important to talk about the securing the intelligence of things. It will become vital because those data can be hacked. So we need to gain kind of innovative ideas from all this. So it comes again to what we have in terms of the revolution that smart networks need. So try to look at it. We talk of smart meters, you talk of smart in network, in terms of transportation, in terms of production of electricity. How do we reduce customers' bill? How do we read the customer's meter, just like what we have here in Sweden, that People can read your meter without coming to your house. You don't need NEPA man. Something happened in a particular place in Africa where the NEPA man came to collect the bill. He went to cut the cable for those who have not paid the bill. And then the villagers gathered and, took him up from upstairs. Imagine. So, you can see this thing in developed country where you come in to take, to read meters in people's houses. Because those who don't want to pay the bill, we want to threaten your life. So, a lot of things is coming up. So we have smart networks, we have smart system, and then we have, like I said, I wrote there, tomorrow's electricity networks will be smarter and greener with a focus on efficiency and reduce consumer cost. To achieve this, we need to explore how competencies in augmented reality, big data analytics, cloud, and cognitive computing can be applied practically. We're not just talking about theoretical implementation, can be applied practically to operating electricity distribution networks. So, for example, what happened in the UK, the pressure is piling up on distribution network operators to save on consumer bills. In other words, you can project what kind of bill you want. You can project you can use AI to say, okay, I've consumed this kilowatts for this month. What can I do to make sure I don't have this kind of thing? Then I need to start having smart bulbs, because one thing leads to another. You need to have smart bulbs that make sure your bulb, does not radiate more than 60 watts. So with the deployment of network sensors, cloud computing, and artificial intelligence accelerating, we know that Energy 4.0 is just around the corner. So the energy sector is based on data and artificial intelligence. It's increasing. So we need to decentralize it. Redefining the generation, because we have different aspects in terms of generation, distribution, consumption, transportation, models using this so-called Energy 4.0. But the good thing about it is that we can digitalize this energy system and utilities towards Energy 4.0. And these transformations are supported by AI technology. This is very good research. So for most of you who are into research areas, I brought out these points for you. If you want to look at AI in terms of Energy 4.0, look at cyber physical systems, how it's applied to energy efficiency. These are hot areas, hot research areas that could change a generation, that could help any country, that could help any industry. Now, number two, optimization and control of power generation plants. Artificial intelligence-based demand response. That means I could say I don't need the lights today because there is nothing I'm doing with the light, but I need an AI to let me know that I could demand that I don't want this bill to be more than this. It's already done in telephony, where you program your telephone system, you remember network, after 2 gig, it cuts you off. Can we have that in electricity? Predictive maintenance and machine learning apply to energy assets also. Industrial Internet of Things in energy management, how do we bring IoT into it? How do we bring smart grids, industrial smart grids, in terms of using the transportation, distribution, and energy, even in storage? How do we store them in, how do we store? How do we know that we have stored enough to maximum capacity that could be displayed, maximum capacity that could be transported, maximum capacity that a town will not need more than that, so that you can redistribute it to other towns that also need it. How can you redistribute it to areas where you have companies, major big companies? Because those areas will need more power, they need more energy than those ones in the rural areas. So norms and standard is also very important to research on, related with power quality and disturbances. So in summary, in terms of this, you see that energy efficiency optimization brings in into what we call complex algorithm to model, interlink system, forecast consumption, and detect non-intuitive, intuitive and holistic optimization that cannot be set by humans due to the complexity and huge amount of data. So we now also begin to look at the areas where we talk about automation and scalability of actions, data management, selection, contextualization, leading to relevant and repeated optimizations. These are all the good things about it. But like I said, why is AI? Why is it the future? Because collecting the data allow real-time monitoring of the behavior and energy consumption of each item of equipment, the interaction between them, the energy consumption of the entire factory as many influencing parameters, like production rate, product type, energy type, equipment, retrofit, building abstract models, like what we are currently working on, we call it digital twins, replacing reality as closely as possible. So it is mandatory to identify opportunities to optimize energy using AI. So optimization algorithms, for example, for energy saving, on-site processes are supervised by expert system. Phenomena are already well modeled by the company because for anything for you to do, you have to model it based on where you want to apply it. So no modeling procedure will be known, but with the AI, you don't need any modeling procedure. That is what we call the next generation AI, where we are moving into non-supervised, section. So only already known set of flexibility parameters should be considered. Exploration of never before seen scenarios can also be appreciated. So then we go into automation, very important. How do we automate it? How do we automate the energy? So creating a digital twin, for example, represent different assets, flows, and sensors dynamically linked. So automatic anomaly detection, so also know when hackers, intruders come into your system. So the magic behind data science actually lies in the data. If poor data is input into your system, then of course, poor results will follow. So why is AI also the future? Talk about automatic data enrichment, creating data from existing information enables the existing data to, from an item of equipment or factory to be enriched. So it means that any data that is missing can be compensated. So automatically calculate its new properties based on a small amount of information. It's just like saying in WSN, where two sensor nodes, we call them the cluster heads, and some happens to die because of battery or because of water, carry the part of the sensors. Another sensor close by will take over. Can we have that done in an Internet of Energy? So therefore, from power consumption, like a pole can be down, can another pole take over from what the other one was doing without a breach of electricity stoppage? So we have access to energy consumption, integral part of the power. We have the flow rate production, the volume produced, and specific consumption that people need, not what people want, what people need. It's not people who use on the light and leave it, what they need, so that we can save energy and have a green environment. But this is very important. This is why we are here today in this conference, because we need the people. We don't have the people. So we are trying to make sure that everyone, in the academic, in the industry, even in the government, that we're able to have people come into this, just the way we have it in cybersecurity. They don't have the training. Good enough, we have this kind of conference coming in for the training. With high turnover, it's expected to be huge in terms of the kind of money that is going to generate. It's not only just the money, it's also a lot of losses that needs to be covered. Then for some of you who are thinking of going into energy experts research and opportunities, then you begin to look at how do you make a proposal in all this I have listed. You begin to think of the introduction, what, why, how, literature review, methodology, preliminary data, statement of limitation, conclusion. Once you're able to analyze your area of research, you could be able to add substance to AI and Energy 4.0. Then we now look at the industrial Internet of Things in energy management. How do we combine two of them? So we applied it into consumer markets to a wide variety of uses. What do we see? We see that IoT application works by taking a common device, for example, a tire or a speaker, and making it smart by integrating several technologies, most of which only become practical over the past few years. So our target is low cost, low power, battery-equipped sensors, that could help in terms of tire pressure sensors in a vehicle, or motion and ambient temperature sensors in a home. So we also look at areas like wireless and wired communication network with data interpretation by local and internet cloud-based intelligence. But the important thing is using digital dashboard for Internet of Energy. Human operator via a smartphone or tablet or mounted or vehicle, this information can be monitored. No specialist can monitor it. You don't need to be trained specially to use this system. So in other words, IIoT applications start with number one, common industrial devices. For example, the steam traps, pressure relief valves, and heat exchangers. The applications take data from industrial sensor and add networking mechanisms and dashboard. Now, the key difference between this is that between consumer and industrial capabilities in this context is the need for open standard and much higher expectation of reliability and security. So IIoT application, for example, uses the steam traps and pressure relief valves and works on them instead of having the steam traps because they are mechanical components. So they have no means to detect and a signal failure electronically. So we also think of heat exchangers and pumps. This is where IIoT is important. Constant variation can impact product quality and lead to premature wear of heat exchanger. We also look at electrical switchgear. Failures of electrical switchgear can cause process downtime, fires, or explosion. So, but IIoT applications bring the promise of improved efficiency, reliability, and safety. Look at what I've been saying. Ability to have detection, prediction, and response matters so much because it gives us the kind of different high utilization or different ones you want to use. Then we also detect anomalies with the intention of energy optimization, predict consumption, manages energy contracts, holistically optimize every process and factory for industries, measure savings and manage performance contract, for example, in the companies that are being run now in the UK and facility managers. We also holistically optimize factory context equipment, bringing flexibility to it for our OEM and system integrators. But the good thing about this is that you can have practical application of this once you have the data. This is a practicality of some of the things we have used. And some of you can also go into it when you have your Python development, because these are free tools that you can use to develop, most of these things that we are using. And then we move into the industrial smart grid. Artificial intelligence, for example, like I've said, all is in the power grid. Smart grid, sector coupling, monitoring of the grid, coordinating of maintenance of work. We have the virtual power plant, coordinating of decentralized plants focus. We have the power consumption in smart home, smart meter, smart bulbs, anything smart. We can make our fridges smart. We can make our pressure cooker smart. AI, then look at the trading aspect. How do you forecast? Algorithm trading, algorithm monitoring trade, to help investors to invest in this area. Then we have a cognitive power plant. For example, this is a current project that is being run in some part in Africa. They call it vision of a cognitive power plant, looking at shutdown prevention, unified subsystem, optimized operation, uptime optimization, proactive maintenance, and agility, safety, and environment. So the idea is using a cognitive power plant project, we can use artificial intelligence and technology developed by that company Beyond Limits to monitor the facility operations so that we can have better thing, better service, provide rapid, near real-time, actionable intelligence, giving operators to the next best action that recognize, mitigate, and prevent problems in these rural areas in Africa. So look at what Samsung is doing, SysMec is doing, industrial smart grid, looking at smart grid driving intelligence, where you can monitor anything from anywhere in part of the world. And then we have the conclusion. Now, the good news is that AI on energy will evolve into energy efficiency, optimization, complex algorithm can be modeled, they can be interlinked as a system, forecasting different kind of consumption, and also checking the non-intuitive and holistic optimization that cannot be seen by humans or cannot even be reached by humans due to the complexity and huge amount of data that is involved. This is where AI comes in. The opportunity to optimize using AI is enormous. And I welcome every one of you to be part of this AI, especially the next generation AI. Thank you very much.
Thank you, Dr. Celestine. Yes, Education 4.0 is evolving with time, especially after COVID pandemic. Enlightening us on Education 4.0 as per industrial revolutions, its major trends, smart networks, various research topics on 4.0 IIoT versus IoT in energy management were all really refreshing, sir. That was amazing. And thank you for joining, devoting your precious time and knowledge with us.
Visit our website, citeracademy.no, for more information about our training programs, boot camps, courses, conferences, research publications, Microsoft and Cisco certifications.